Hi, alright, so this is our Rube Goldberg machine with me and Dean. It took a lot of effort and a lot of brain power to come up with a
Blood, sweat, and
project
tears.
like this.
Yeah.
So why don't I give you a little tour of our project here? So it starts over here, as all things do start out with a Wii Fit. So we've got and we're going to start off by pushing the car into the Wii Fit, which is going to impact upon all these 1990s financial textbooks. Going to smash into one another. In a case of extreme irony, we actually have our physics textbook participating in the actual Rube Goldberg machine. We're going to continue until we finally get to the Spanish dictionary. What that's going to do is slam into this pole right here, which is operating almost as a lever. And what that's going to do is turn the marble and slot it into this other tube down here. The marble's going to continue down and going to hit this marble over here, continue along this tape-made track and hit this other marble. That's going to go down and go down that pipe down there, which is going to hit the pool ball on the ping pong paddle, which is going to continue down this track made out of hockey sticks until we get to this cup pulley system, which is ultimately going to give the big reveal for our simple task. So one thing that our Rube Goldberg machine really showcases is Newton's 3 laws of motion. There's a lot of energy transfers here, and Newton's 3 laws of motion really show you and explain some of the inner physics behind such transfers. Now would be a good time to mention that we have over 20 energy transfers in our Rube Goldberg machine, far exceeding the recommendation of 15. So we just hope there's some extra credit points at the end somewhere. So Newton's first law says that an object at rest must stay at rest until acted upon by an outside force. Now the beauty of our project is that nothing happens unless we provide the initial push to change our Rube Goldberg machine, which is currently at rest, into a machine that has forces behind it. His second law is force equals mass times acceleration. Now, this is very important because in order for this section to work, we needed to choose books of relatively similar masses so that we would get the correct transfer and that it would all work. And we also ran into an issue with this with the marble because the marble is so small, but we managed to increase its acceleration via gravity, which gave it the force to push the pool ball. Finally, his third law deals with how every action has an equal and opposite reaction. So we see how when the car hits the Wii Fit box, the car bounces back slightly with the same force that it impacted, that the Wii Fit turns over. So we see these books turning over. We see how that there's equal reactions to every action we see. For example, when the marble hits the pool ball, it bounces back. So there's always an equal reaction of force for every action that we completed. Another key principle in the world of physics is the conservation of energy. The conservation of energy rule states that energy cannot be created nor destroyed. So that's why we had to come up with clever ways to derive energy from our surroundings. So not only, most of our energy is derived from the initial push that we give to the car down there. There's energy from this system here with gravity controlling most of the descent down here, and then finally there is a lot of gravitational energy here dealing with our pulley system. So we're not creating energy; we're merely using the energy already present around us. Another key principle of physics deals with the law of conservation of momentum, basically saying that the momentum present in a system before a collision is equal to the momentum present after. And the same thing holds true for two objects. During their collision, they have the same momentum before as after. And we really see that highlighted in our stacks over here, where when one book hits another, the same momentum that was present at the beginning carries through all the way to the end and really carries through all the way throughout the rest of our project. So both the law of conservation of energy and the law of conservation of momentum are critical to the operation of our Rube Goldberg machine.
Rube Goldberg machine, ready? Go.
All ready. Oh man, oh, it's going, oh! Oh my God! Where is it? Oh! There we go. All right.